Please say again, I missed that.
Perhaps Byron would be able to get to it when he's assigned to sample 311 alpha.
Okay, I copied 311 alpha, but is that the IHF number, the only one you want me to copy?
That's one of the two. We're going to do the installation of two samples, the first being 311 alpha into the left port and 312 into the right port. Your procedure pages are Foxtrot 600-11 and Foxtrot 600-12.
Okay, we've got that, and we'll get added just as soon as we can break away from the other two or three experiments we're running.
Okay, thanks a lot, Owen.
And Owen, one more quick item. We are going to be running the forward bulkhead cameras Alpha and Delta in prep for the cargo bay and for looking at the space lab, and you might notify Brewster of that. And Enco's going to be... Okay, Enco... Go ahead. Okay, in the blind, and Enco's going to be controlling those cameras, and we'll see you at about 4 plus 8.
Okay, Bill.
Space Lab, this is Marshall Ops. We have you for 2 minutes through Aurora Valley. Space Lab, this is Marshall Ops through Aurora Valley. How copy? Bob, we copy, but you may not be able to copy us. Go ahead. Space Lab, Marshall Ops, we have you on S-band for approximately 30 minutes, Bob.
Marshall Ops, this is Space Lab. Go ahead.
Yes, Ulf. The 300 people are anxiously waiting a status on 300.
Okay, we have started the IHF at least 4 times already. And
No,
the
it's the
iso-obslam is on again. I'm talking about the isothermal heating facility. We get the same problem again and again, and that is a stop with, and that means that
You're dropping
the
out,
system does not reach. Okay, and finally we managed to set up the fluid physics module. We have that one screw out, but don't ask how.
Okay, we copy that you got the screw out on the FPM. Thank you.
And I'm now waiting for the iso-obslam of the isothermal heating facility to start to flash. And after that I will set up the gradient heating facility.
Roger, we copy, and good job.
All right, boss. I'd like to get in contact with him. Slopes, are you still online? Marshal Ops, this is Space Lab.
Go ahead, Ulf.
Okay, one more thing. We started also the cryostat, and that was complete at 22 hours 00 minutes. So that is basically on time. Only 10 minutes delay.
Roger, copy. Go ahead, Bob.
So, who's this?
This is your friendly CIC.
I was looking for Houston. I didn't call POCC.
Okay, Bob. Touche. We didn't copy you. We'll get him on the line.
Yeah, I'd like them to come up. I need to talk to you about a systems thing here.
Roger.
Columbia, this is Houston Space Lab, Bob. We're standing by.
Okay, lyo canisters. I did not change the lyo canister last evening about 20 hours, wherever it was, because Brewster and Owen were working in front of the workbench rack and I couldn't get at it. So I left with the idea that they would do it, and they said, yeah, if you guys start inquiring, they'll do it. But apparently you guys never inquired, and I realize now that we have two canisters which have been here now 48 hours, and I suspect I ought to go ahead and change both of them. Do you agree with that?
We'll check on that for you, Bob. Just a second.
Marshal Ops, this is Space Lab.
Go ahead, Ulf.
Okay, we have that stop, and I'm just going to display it now at least the 5th time. It's the stop 136, and I think it doesn't make much sense to press on here. I'm probably better off if I go to stop the GHF first and give those PIs a chance. Can you talk to 300 people and give me their input?
Yeah, they're talking to me in the ear. Ulf, stand by. Ulf, we would like to suggest that you put some additional pressure on the two feed-through connectors and try it one more time.
Okay, say again. Try it one more time, but do what else?
Put some additional pressure on the feed-through connectors and keep it there for the whole 15 minutes or thereabouts.
Okay, what I try to do is to tighten the ports on port 1 and 2 more, but I think it does make sense to reconnect the electrical connectors because that would not seal it. There would be a problem.
Okay, I think you misunderstood, Ulf. We want you to apply some pressure. Try to hold it together till we can get our vacuum on it. We don't put pressure on the connectors while you're trying to pull a vacuum.
Okay, pressure on the connectors. We'll try.
That's good. This was one of the fixes we did at the Cape, and it worked fine.
Okay, I gave the start IHF 1, enter.
Space Lab, this is Houston on air to ground 1 for Bob about your CO2 cartridges.
Go ahead, thank you.
Roger, Bob. They haven't seen any buildup at all in CO2 either in the orbiter or Space Lab, so what they'd like you to do is just go ahead and change D. That's only one canister D.
You want his position alpha changed out, correct?
Bob, we were assuming it was a Space Lab canister you were asking us about, and in that case it would be location Delta.
But we're talking about the Space Lab. Okay, so the Space Lab, we have position A and position Alpha and position Bravo. And position Alpha was supposed to be changed out after 1 day. All the others are on 2-day cycles intermixed. Now you're telling me I have to just change out the one that was supposed to be changed tomorrow and not change the other one.
Okay, Bob, if they're called Alpha and Bravo, that's fine. Change out one of them.
We have position Alpha and position Bravo called out on the cue card. The other question is that the numbers of the LIO canisters, which are numbered in the orbiter, are not numbered on ours, and so I'll just put one in and make marks. But it's not going to be number 34 or 35 or something, because we don't have such numbers back here.
Roger, Bob, that's fine. Just mark the ones that you've used so you don't reuse a already used canister.
Roger that. Charlie. Marshal Ops, this is Space Shuttle.
Go ahead, Ulf. This is Marshal Operations.
Hey, Mike, nice to hear you. We have the same IHF stoplight another time. The ID code is 136.
Yeah, we copy. I've just been talking with Mel Brooks about that problem, Ulf, and he has a procedure that we think will allow you to change out the right-hand flange, which is our most suspect flange, and allow you to replace that with one from stowage. If you have a minute, I can read up the procedure which Mel has recommended that you try and implement, or that you hand to Byron as you go off shift and ask him to try and implement it as soon as possible.
Well, I can wait until, if it is only for 10 minutes or something like that, it's no problem.
Real good, Ulf. The procedure is as follows, if you're ready to copy.
Okay, wait a second, let me write it down. Okay, Marshal Ops, this is PS1, ready to copy.
Real good, Ulf. We have about 4 minutes of AOS left. The first step is to enter at the CCO, start IHF 1, enter. Second, after 2 minutes, halt IHF 3, 1, enter. And then, to open up the flanges and unlock them, open 1, 7, 4, 3, 4, 6, enter. Your echo should read 3401 07 04 03 04 06 14. Go ahead. Okay, then your close should be as follows. Close 003 000, enter. At that point, your echo will be 4400 00 03 00 00 14.
Okay, let me read back that close. I'm not sure whether I have all the zeros. Close 000 3000. Is that correct?
Negative. You have an extra zero. What your close instruction ought to read is close 003 000. Enter. And Ulf, we have about 2 minutes to LOS. At that point, having done those keystrokes, you're ready to remove the right flange using your usual flange extraction tool. From storage in Romeo 10 Echo, in the lower drawer, you'll find a spare replacement flange. Its item number is 300.07. Take that replacement flange and put it in the right flange position and continue with start IHF 1, enter. And it may be of some benefit to apply a little force to those connectors during the pump down. And Space Lab, this is Marshal Ops. For Ulf, first we do need to remind you to do your experiment 30 electrode check and battery check before you go to bed. And the other thing is that we gave you the wrong stowage location for that flange. The correct location is Romeo 10 Charlie.
Okay.
Thanks a lot, Ulf. See you next time.
Hey, we got our experiment ops on. Everything looks to be normal down here.
Very good, Owen. Owen, this is CPAC. We have indication of a first MPD firing.
Got the same indication on our display here, right?
And number 2. Space Lab, this is CPAC on air to ground 1 for Owen.
Ed?
Owen, we don't see any MTV picture down here. Could you confirm that it looks like it should be on from up there?
Yes, I did inhibit while we were on the daytime side. I'll have to go put it to enable. The Byron just got it, and it's a rather bluish-colored flash of very short duration, so there was another one, and it does not have any strong directional characteristics. It's more or less just a uniform hemispherical glow, bluish color, coming from the general area of the MPD arc. There was the next one.
Space Lab, in order to allow you guys to verify that we're getting good MTV data, we're going to route that MTV signal to your monitor Bravo.
It's already done, Mike.
We hope you see your MTV on your own monitor. Now we're seeing it down here.
It's just a single bright pulse. There's no indication of any field alignment at all.
CPAC copies.
That's about as bright as a beacon on an aircraft liner.
Owen, this is CPAC. I can barely hear you through the cheers in the background.
Okay. It wouldn't surprise me at all if people could see that from the ground.
We're seeing it here in the POC.
I was, of course, meaning by eye if they were at the right location.
Well, I hope somebody's looking, Owen. Owen, this is CPAC. How big would you say the sphere was? What diameter?
The brightest part, which is sort of saturated in the eyeball, I would guess to be about 1 meter in size, and then the intensity diminishes over another 4 or 5 meters away from that. So it's a real bright central flash, then just exponentially decaying over the next 5 or 10 meters.
What would you say the exponential decay length was?
How about 1 meter for the decay rate? So I can't see any decay in the first meter or so. It's just too much of a single bright flash. But beyond that, then I would something between 1 and 2 meters is the scale distance.
CPAC copies. Space Lab, this is CPAC on air to ground 1 for Owen.
Ed?
We hear nothing but superlatives here.
Say again, Roger.
It's Bill, Owen, and I hear nothing but superlatives.
Oh, great. Well, it's all your equipment down there. I'm pleased to see it's working so well.
So are we. Owen, about 2 more minutes, and then we'll go to 4 NGP firings, which we do not expect to be visible.
Okay, that's fine. And the air glow is really quite interesting here, too. As we get a little closer to sunrise, the air glow layer is coming closer and closer to the spacecraft. So we got a lot of good air glow. There's a little vernier thruster firing. And that really brightens up the tail glow on both the vertical stabilizer and the right engine pod.
CPAC copies.
Break, Marshal Ops, PS2 for the MSTR people. Mike.
Go ahead.
A quick question. I've got the samples stored in the IHF, 311A on the left, 312 on the right. Do you want the dummy plug to stay on for now for the second port number 2? Do you want me to put it on to the sample flange?
Okay, Byron, I copy. I think what we want is the thermocouple wire hooked up on the left and leave the dummy plug on the right. But hang on, I'll just check with 300. Okay, Byron, connect both connectors. Remove both dummies and hook up both wires.
Okay, will do.
And Byron, the sample codes you're to enter is the sample code for the 311 alpha sample.
I understand. Here's the next, the first NGP pulse.
CPAC copies. Okay.
Marshal Ops, Space Lab, PS2.
Go ahead, Byron.
Another question for the IHS people. I took the sample out, or the dummy connector out, and as you know, Wolf had to do some jury rigging. And it turns out the new sample flange doesn't have the LEMO connector oriented in quite the proper position to fit in easily. I think I can twist the wire to make it fit, but it's going to be a tight fit, over.
Okay, we'll check with the PI. And their message, Byron, is try to make it fit if you can.
Roger. The CPAC, I can see now from my procedures here that in the last minute you had some 1/10-second firings of the NGP. I was looking out at the time and could not see any indication of those firings. We're, of course, in off sequence now.
CPAC copies.
And Space Lab, we've got you again inside on TV.
And we have a message for Byron. If you're not able to get that connector to fit onto the flange, 300 suggests that you simply put the dummy back onto the cable and get at least the first sample started. We, of course, hope that you'll be able to get that cable on there for us.
Okay, Mike, we copy. The way to rotate that whole connector inside the sample flange at all?
Stand by.
Space Lab CPAC to Owen, thanks very much for your help during this last FO. It looks like everything went all right.
Yes, indeed, sure looked fine. I guess you are expecting the same thing for the EBA, aren't you?
Say again, Owen?
And as far as we know, the EBA should perform just as well.
It certainly should, Owen.
Space Lab is Marshal Ops for Byron. 300 recommends that you try and install that in as close an orientation as you can, but when you got it installed, just put the dummy plug back on the cable and get the 311 sample started. We're trying to keep reasonably close to our scheduled timeline of sample changes. Space Lab, this is Marshal Ops in the deaf or blind or whatever you call it. The 300 team says that, yeah, the best thing to try and do is install that with as close an orientation as you can get it, and use the dummy connector if the cable doesn't reach, and in any case, get the 311 alpha sample started as well as soon as possible. We're trying to keep close to the timeline. Thanks.
Space Lab, this is CPAC on air to ground 1. How do you read?
Loud and clear, Roger.
Could you give us a confirmation of battery charge start, please?
Okay, I've not started the battery charge yet.
CPAC copies.
And Byron, if you have a chance and you get up by the tape recorder on 101, you might give us a read down this pass.
Okay, stand by. Okay, on the Marshal, we just gave that 501, we gave the resume to the ISO, the IHF, and we're in a steady ISO ops mode now. Both port unlock lights are off.
And Byron, you were garbled on that transmission.
Roger, the resume to the IHF was given at 5 hours and 1 minute MET, so it's back in business running.
Roger, copy. And Byron, I'm not sure if you copied my transmission on the VTR on 101. Give us a reading on that if you have a chance, and there's no need to push any of the buttons on the tape recorder if you have some unusual lights.
Okay, I see 632 on the tape recorder for 101.
Roger, we copy 632, and we appreciate it. Thank you.
Yes. Yeah, charger currents are reading 0.1 amperes. Marshal Ops, did you hear the last?
We need you to repeat, Owen, you're breaking up.
Okay, both charger currents are 0.1 amperes.
Roger.
CPAC copies.
Space Lab, this is Marshal Ops for Byron.
Go ahead there, Marshal Operations.
Right, Byron. I'm just wondering, did you give us a tape number on your VITR tape changeout about 2.5 hours ago?
Negative, I didn't. It was tape number 5.
Tape number 5. We copy. Thanks a lot.
Yeah, Marshall, lap, Space Lab.
Go ahead, Byron.
Okay, I've got some free time here. I'm going to try and catch up where I should be on 330. It's okay with you guys?
Yeah, go ahead.
Okay, I finished up through step 719, which is the end of the annulus preparation. I'm ready to go on to step 8, section 8, which is the oscillation frequencies.
Okay, and we're following the procedure down here on the ground?
And you might tell the MSTR people that in the beginning I had my visualization lamp all the time, and about after the first or second camera run, it went out. So I'm not sure if it's blown out or what, but I've got to use the camera on a very long interval and brief exposure to get any illumination in there whatsoever.
Where is the problem at? We copied what you said.
Yes, Byron, we
The
understand
problem is in the visualization.
we
The
understand
visualization lamp and the fluid.
that the visualization lamp seems to be out. Hope you can work around that using the camera lamp.
Problem. It didn't work.
It's possible later also to observe the meniscus on the cylinder and see possibly a similar effect that you notice on the analyte container. Yes, 330 PI, air to ground 1.
Sorry, I didn't copy that one. Say again, Jan, please.
Okay, Byron. I still have the lateral shift at 0.9 millimeters. Did you copy that?
I copy that.
Do you get the same readout on the display that you are looking at?
Okay, I see it now.
Okay, because when you use the viewing aid, it may run into the viewing aid.
Roger, understand.
Okay, thank you.
Okay, the box is in now, and I have a bubble in the middle. Well, it's not quite in the middle. It's about 2/3 of the liquid is up towards the top, which is towards the front, 1/3 towards the back.
I copied that, Byron. Is it a stable bubble, you think? Or do you think that the 2/3 can be changed easily to another value?
Let me see. Okay, now I've got, by shaking the FPM, I've got the majority of the fluid towards the rear plate.
Okay.
Oh, with our oscillation here. The other interesting thing about the annulus container is it seems like the most of the tracer particles stuck to the sides of the container. No matter how hard I shook it, I was unable to get them free. That looked like the case also in the box initially, but now as I look at it, the tracers are quite visible. So the box will be good data with tracers.
I copied that, Byron. But did you see a change when you wet wipe the container? Because it could be an electrical effect that aligns the tracer particles, and that goes away if you wet wipe the container.
Sorry, I didn't understand that. Could you please repeat?
Okay, the adhesion of the tracers could be an electrical effect, and it should go away if you wet wipe the containers.
It looks like the box is in. It looks like for both of these, the annulus and the box, the resonant frequency is substantially higher than one might have predicted. It's up 1.5 hertz or more.
Okay, I got 1.5 hertz at step 10.1.
I haven't quite gotten there yet, but it's pretty close. Still stepping up the frequency slowly.
Okay.
Space Lab 1, this is Marshal Operations for Owen, if he's handy.
I'm tucked under a shroud right now. Can you hear me, Mike? Mike, you copy?
Yep.
Owen's up under the shroud in the FU port. Okay, I can hear you. Go ahead, Mike.
Okay, Owen. Let me see. We just had a question. We were trying to do some commands to TV camera number 2, and we're unable to do that. We suspect we may have the wrong cable used to connect the camera number 2 to its cable bracket at overhead 7 Lima. And if you happen to be near there, we'd be interested in getting that cable number.
Okay, I'm under the shroud, cannot get over there, but I've not changed anything since our last run except to turn the camera power off.
Yeah, we had trouble during that run trying to get some commands from the ground is all.
Well, they're both set up correctly, Mike. Guaranteed. Although camera 2 is not looking at anything but the floor right now.
Okay, we understand. There evidently is a possibility of using a Space Lab cable or of using an orbiter cable, and we were just trying to distinguish which one that happened to be hooked up.
Ah.
One of those two allows us to command the camera from the ground.
Okay, that's a very good point, and I'll bet I've got the orbiter cable. Says RCA 22932 Bravo 4-503, TVC cable serial number 002.
Can you read back that slowly, please?
Okay. RCA 229er space 32 Bravo 4-503, TV cable serial number 002, and I bet that's from the orbiter.
That on TVC 1 or 2?
Is this on connected to TV camera 2?
Confirm.
Okay.
Switch him out if you want.
Okay, we're going to go try and identify.
Try
We're going to go try and identify that cable.
I'm almost positive I brought that in from the orbiter.
Yeah, thanks. We understand you're pretty sure you brought that in from the orbiter.
And the Space Lab for the 330 PI.
I copy, Brian.
Okay, I'm searching for a resonant frequency in the box, and I'm really unable to get anything that is even out of phase up over 2 hertz. So I can get a pretty good amplitude at about 1.6 to 1.7, but it's still pretty much in phase.
Okay, and that's at step 10.1?
Confirm.
Thank you.
Affirmative. 1.7.
I copied.
Jan, I'm not sure you want to take 500 frames of this. It's not all that interesting.
No, but okay. The thing is, when you
Well, we can do it. I mean,
no, but if you start rotating, then you won't be able to see very much. If you think
you're right. Well,
if you start rotating, you won't be able to see very much for the later stages. So it may be better to spend it on the things that you can see very well. But if you think that the thing stops already soon after start, there's no sense in taking that many frames. So
well, now that I look at okay, break. Now that I look at it, you will be taking the spin up, steady state, and spin down. Will be reasonably worthwhile.
okay.
Space Lab, this is Marshall Ops. We've a request for Owen, if he's handy.
He's not too handy right now.
Okay, understand.
All right.
Okay, that finishes up to step 10.6.
I copy, Brian.
Okay, Mike, what's your question?
Oh, right. We would like one of you guys, I guess Owen, to run Mal 1.6 for experiment 1. It shouldn't take you long. What we need is XX equals 16 and YY equals 89.
Stand by, please. Mike, the telemetry, the teleprinter uplink just asked me to go up to the payload bay cameras to do some contamination studies. You want me to do that or stay here to run this Mal?
Stand by.
He says he can get the Mal. He says he's going to get the Mal, so I'm going up to the flight deck.
Oh, that's great. That way we get both. Thanks a lot, guys.
Hey, Mike, you want me to do a manual mode here on FO16 mod 89, is that right?
That's correct. The idea is to interrupt the auto sequence by going to that value of XX is 16, YY is 89.
Okay, you ready for it now?
Yeah, we're ready for it right away.
Got it. Those FO running.
Yes, 330 PI.
I'll let you go, 330 PI.
Okay, Byron, can you be in a somewhat mumbling mode and tell what you are seeing?
Okay, we have the box rotating now, and there's a lovely bubble in the middle of it, and it's very difficult to see any type of resonance right now.
Yes, that's what I would imagine, but, well, do the best you can.
I think we'll try 1.9 hertz, about the best we can do.
Oh, I copy. Yes, 330 PI, air to ground 1.
Ed?
Okay, Byron, can you tell me what you estimate the oscillation frequency was at step 10.8?
Roger, 1 decimal 9 hertz, about the best I could tell.
I copy.
And Michael, you'll be pleased to know there's no California surf up here in the fluid physics module.
We're delighted to hear it. Also wonder if you've seen any evidence of any electrostatic forces, a liquid clinging oddly to surfaces or anything inside Jan Vreeburg's containers.
I really haven't. The only thing that gave me any real puzzle was that annular container. And there have been some electrostatic forces there. I did wipe it and I tried to shake it again quite a bit when I took it out, but very few tracers visible. And the liquid seemed to behave very smoothly, but it was like it was very viscous, you know, and just didn't want to move around very much.
Understand, you got slow motion on the liquid surface inside the container. We'd sure love to see some video of that.
Absolutely. I know, I would too. I'd love to show it to you. There's absolutely no motion of the fluid up to about 1 hertz of oscillation. Stays there with, goes with the container.
Right, we copy. Thanks, Byron.
And we're showing about 2.4 hertz now on the
And
25
Byron,
RPM run.
Byron, the Experiment 1 team would like you to do that mal before 6 hours, 38 minutes. That is, say, sometime in the next 10 minutes.
Yes, 330 PI, air to ground 1.
Go ahead.
Okay, Byron, did I read correctly that you said the resonance frequency at step 10.11 was 2.4 hertz?
That's affirmative. That's the best we could find.
How can you get to 2.4 hertz?
Put it on the dial.
You mean the machine operates to a higher frequency than 2 hertz?
Affirmative, just like the trainer does.
Yes, I remember.
Now, break, Michael, I already initiated the FO1689 and it's running right now.
Terrific, Byron. Thanks a lot. Appreciate you helping us out on that one.
Okay, 330 PI. I just finished step 10-13, and when I spun it down to 0, I was able to stop the container broadside. The particles didn't quite finish moving by the time the camera rolled out, so I ran about another 20 to 30 frames infinity to try and catch the final motion of the tracers over.
Oh, thank you. That's very good, Byron, that you were able to stop it in such a beautiful position. But those last 30, 40 frames are not the most interesting, so I shouldn't worry about that. I'm not.
Okay.
Byron, another...
It's difficult. It just...
Byron, are you still there? Okay, Byron, do you read me? Yes, 330 PI, air to ground 1.
Loud and clear.
Okay, Byron, I think when you get to the preparation container, I would like you to watch carefully the difference between the wetting characteristics in the two different cavity shapes.
Roger, understand. I've got it out. Got it out now, and it looks like there's some particles that are on the cylinder walls. I'll shake it as best I can to try and get it all loose.
Okay, but the cylindrical cavity is treated with John Paddy's surface material, and therefore should show a different wetting angle than the annuloid cavity. Can you see that difference?
Yeah, I'm sorry, which one has the anti-spread compound on it?
The cylindrical one has the surface material on it.
Okay, and the annulus does not, is that right?
Right, that is affirmative.
Okay, well, it's very difficult to see till I put it in the viewing aid here. I don't really notice too much difference between the two right now.
You don't, huh?
One note for the MSCR people, I didn't find any wet wipes in 08 alpha.
Okay, we copy that.
Yes, V30 here, air to ground 1.
Roger, go ahead, Jan.
Okay, Byron, did you already put in the combination container?
It's in right now, and I'm just getting it set up so that the cylindrical access is horizontal here.
Okay, thank you. Yes, V30 PI, air to ground 1.
Okay, go ahead, John.
Okay, Byron, we don't have any data at the moment, so would you please read out what you find on the oscillation frequencies?
Okay, what would you like me to read out? I'm sorry.
Okay.
We're beginning to find the oscillation resonance frequency for the cylinder now.
Okay, I'm standing by.
And it looks like here we do have a meniscus. It's filled a lot more fully than the other one. It looks like there's only about maybe 1/5 of the available volume is air in this particular container.
Could you repeat that? I didn't get all of that.
Roger, it looks like there's a much smaller bubble in this particular one than the others you've been using.
Okay, yes. ES2 is reassured here. Air to ground 1.
Roger, go ahead, 330 PI.
Okay, Byron.
Roger, go ahead.
Okay, Byron. Will you watch for a particular observable phenomena, because we have to run out the film at the end anyway. It's not worth storing. So if you see things that are extremely interesting, you can either spend a little more film or try to do it at the end.
Okay, I think maybe we'll try and hold on and do it if there's anything at the end. I don't see anything really spectacular than change in numbers and a little strange behavior. I'm going to go ahead and do the cylinder now. It's 0.55 hertz is the F0 at step 12.1.
Could you repeat that?
Roger, step 12.1 is F0 of 0.55 hertz.
I still didn't get it, Byron. Once more, please.
Stand by. The resonant frequency here is 0.55.
I read back 0.55. Is that affirmative?
Affirmative. Good copy.
Thank you, Byron. That's very good value.
Okay, and we got a 01 timeline shutdown message, and that just means go back to manual, I think. Mike, I still show an FO running light here on the depth.
Repeat, Byron.
Roger, I still show an FO running light on the 01 depth, and we just got a 01 timeline shutdown message.
Okay, I think that's normal, but we'll check.
You're right, too. It tells me to go to ISO mode to auto, and that's all complete. Okay, the ISO switch is back in the auto mode now.
Okay, Byron, could you put the manual auto switch in the auto mode? That's on 01.
Complete, Bill.
And that's the
Already
reason.
complete, Marshal Ops.
And that's why we got that error message, that 01 TV shutdown, or timeline shutdown message. And the depth.
Roger, copy that, and that's all complete.
Okay, and just a couple quickies. Well, go ahead with Jan, and we'll catch you before LOS. We got about a minute.
Okay. We're doing the, it's an annular chamber now. It's hard to tell.
I copy, Byron.
Oh, yeah, you know what I did, Jan? Mixed them up here. Hey, Jan, when I did those before, I did the annular chamber first. So on your data, you'll see that the annulus was done before the cylinder. Sorry.
Okay, so you first did the cylinder, and then now you first did the annulus, and now you're doing the cylinder. Is that correct?
That's affirmative, yeah. That's affirmative.
Thank you, Byron.
I got a good resonance at about 0.7 hertz on the cylinder.
So that's the higher value.
Doesn't seem to be.
The higher value than you found for the annulus.
That's right.
And Byron, we got you for about 16 seconds, and we'll next see you at Hawaii at about 7 plus 3.
Okay, Roger, Bill.
You did a beautiful job, Byron. Thank you.
Roger, thank you. I think you'll be happy with most of the data. It's just a little perplexing here.
Well, very good.
To the frequency here, you may not be able to hear right now, but it's difficult to see. I'm still checking.
And finally, replace the thermocouple plug, including that 90-degree twist.
Okay. Understand, Mike. Right now, 311 Alpha is in port 1, so you say that's finished. Is that correct?
That's correct. It's finished, and in fact is finished its cool down. So at any time you get the time, you should be able to proceed with this activity.
Okay, so I'm ready to go. I'll do it now while we got you in the loop.
That'll be terrific. We'll follow along.
And Space Lab, this is Marshall Ops. And we've got you...
Go ahead, and I have a question.
Go ahead, Owen.
Yeah, I was just bringing up CPAC, and when I was configuring the panel switches, I got a BAT1 temp 03 message, and looking at it on 02S, the temps on the batteries are all 150 degrees high, out of limits. Have we lost any... No, I guess that's the right temperature, so I'm not quite sure how to proceed.
Okay, stand by, Owen. They are enabled, Owen. Why don't I just put them on the line here?
Okay, we're looking at it, Owen.
Roger.
Owen, we want to do a termination of the battery charging.
Chargers enabled to inhibit, so essentially that terminated the battery charge, and the battery is also off.
Roger.
I think that may be the fact that I don't have chargers enabled. That's right. On this Model 17, we've had that problem before. We don't get the right numbers out when the chargers are inhibited, as they are called to be for Model 17.
Roger, we recall.
If you'd like, I'll turn that chargers enable switch back on and see if that makes it any better.
Copy. And Owen, when we do FO13, the PCAP calls for 69 equals 0 for PCF. And we want to disregard...
Sorry, Roger, I have to say. Yeah, I'd like to get chargers enabled if you agree.
Okay, we're still reading zeros for battery voltages down here.
Battery voltages are reading zeros. I think you'll get good data back, Roger, until you get chargers to enable.
Affirmative.
Okay, I put it to enable, and we now have reasonable data again.
Yeah, it looks good now. And the battery temperatures are fine. Okay, how are we doing for FO13? We'd like to do we'd like you to ignore the PCF69 change in the PCAP.
Okay, I'll not do the PCF change.
Okay, looks like it's too late, Owen. We've got T0 time.
There's 27 seconds left. I'm sorry, yeah, I was counting up. I'm sorry.
Okay.
Got an experiment ops on at this time.
Right, Owen, we're showing that it's running. And we'd like you to do the MTV on when you get in the dark.
Okay.
And Space Lab Marshall Ops to Byron, we have Dr. Mike Haynes on the line whenever you're ready.
And Owen, is the DGP enabled? We don't have data now.
And Space Lab Marshall Ops in the blind, how copy, Owen? And Space Lab Marshall Ops, we've got you through Mila. Space Lab Marshal Ops, comm check. And Space Lab Marshal Ops, how copy? Space Lab Marshal Ops, how copy? Space Lab Marshal Ops, through Mila, how copy?
Loud and clear, Bill. Loud and clear, over.
Okay, we've got some Radicom at this time. Hopefully we'll hang in. And Byron, we have Mike Haynes on the line.
Okay, roger, copy. And is Jan Freiberg still there?
And Owen, we would like to have the CPAC MTV turned on if possible.
I turned it on 2 or 3 minutes ago.
Okay, thank you. We've kind of lost our data, Owen, so we're having a little bit of trouble.
Okay.
Byron, Jan Vreeburg is listening in. He's not enabled for talk, but he's certainly happy to note any comments you might have from his run.
Okay, well, I've got a big apology to make here. When thought I'd set the f-stop, and when I went back and looked at it for Mike Haynes, it turns out the f-stop was up around between 8 and 11 instead of between 4 and 5, 6, which is about 2 stops underexposed.
Okay, understand. F-stop is between 8 and 11 instead of the somewhat faster setting, which he had hoped to get. Understand.
Not sure exactly how it happened, but it ended up there.
Okay, great. Remember, we'll have to push that film when we develop it. Just note down as closely as you can what it was set to, and we'll do our best when we develop it.
That was it. It was between 8 and 11.
Thank you. 8 and 11, we understand. In between there.
And Byron, Mike Haynes, 327.
Well, Mike, I'm just it's taking me a while to get this reservoir out and get it all squared away here.
Sure, just a question in passing, if you have an opinion on the operation of the Vinton camera apart from the aperture.
And Byron, if you're able to talk, we're just interested if you got any start on that IHF work or not.
Yeah, Mike, we did, and I see now we've got an ISO-op flashing and a port 1 unlock.
Okay, real good. Understand. You have ISO-ops flashing and port 1 unlock.
Roger. And if you got the facility people around on the reservoir for the module, the 3 prongs look like launch blocks here in the back of it. And Mike, never mind. I've got them out now. It looks like it unscrews.
And Byron, we may have a temporary dropout here.
Okay, well, I'll unscrew it away, and I don't get anywhere with this launch block, guys.
Okay, we copy. You couldn't get anywhere with the launch lock on the FPM. Is that affirmative?
It's on the FPM reservoir. It's in the tail end of it. There's 3 little fingers that are into a collar in there.
Okay, and you're having trouble, is what we copy.
Both got it out, so we're all set, Bill.
Okay, we copy that you solved the problem.
Oh, and this is CPAC.
Go ahead.
We'd like to know if you can see the electron beam in the MTV.
Well, oh, you mean the PICFAB?
That's a
Roger, you're not talking about C. Okay, just a moment. I'll have to go over and take a look.
Okay, good, Owen. We are talking about PICFAB.
Marshal Ops Space Lab DS2 for the 327 PI, Mike Haynes. Oh, Marshal Ops Space Lab here for the 327 PI. Marshal, how do you read the PS2, over?
We read you, Byron. We're trying to get Mike back on the line.
Yeah, I'm on the line now.
Okay. Okay, Mike, you there?
I'm reading you, Byron.
Okay, very good. Well, when we got the reservoir in and started to bring the fluid out, a little jet of it went all the way in, and you have two types of discs. One is the flat polished aluminum, another one is sort of treated like it's sintered. And the one that's sintered that I have in there is now somewhat pre-wetted because this little drop went flying in there and hit the disc. Over.
Okay, that sounds very interesting. I'd like you to maybe try iso rotation of both plates. That's iso rotation at 5 RPM.
So what I'm saying is I'm still in the setup phase, Mike, and as I was injecting the liquid to the front edge of the reservoir, some of it must have gone kaplot right on into the chamber. And I'm also confused about your discs. I have, looks like several polished aluminum ones and several that are sort of sintered that have a some sort of a particulate surface on them. Over.
Okay, I think for this you should choose a smooth disc.
Okay, I'll replace and put a smooth one in now.
Okay.
No?
Byron, Mike Haynes, we'd like to encourage mumble mode. If you could, just tell us which step you're at.
CPAC from Space Lab. In the MTV, we have a star field, no indication of where it, how close it's pointing to the beam. Did you want me to take manual control and pan around?
That's affirmative, Owen.
Okay.
Owen, PICPAB is through with their operations.
Okay, I did see one flash a moment ago. I would not have thought that was PICPAB.
It probably wasn't. They started, they only go 6 minutes, and they started some time ago.
Okay, I'll continue to pan around just a little bit. Oh, I see. Those are the vehicle thrusters that are firing. I see that flash with the TV.
Well, that's good, Owen. Mike Pond will be very interested in those thruster firings.
We've never had an MTV to practice with in the simulator, Roger, and finding that the gimbal control is very, very slow. It takes a long time for the MTV to move anywhere.
We copy, Owen. And Owen, when we finish about 8:05, we want to remind you to go to the battery charge again.
Space Lab for Byron, Mike Haynes.
Go ahead, Mike. I'm right here.
Okay, Byron, we'd like to know what step you're on at the moment in 327.
Okay, I'm on step 1.37. We've got the setup here, and we're ready to go.
1.37, we read. Yeah, Space Lab Byron, Mike Haynes again.
Go ahead.
Byron, just in case of non-axisymmetric wetting, we'd like to encourage you to rotate both discs, iso-rotate both discs at the minimum speed, just so that we can get a visual check on the axial symmetry of the drop.
Okay, is that before you, that's after we go to the drop, right?
That's during the entire procedure.
Okay, during the entire procedure from now on?
Correct, from start to finish.
Okay, ISO rotation of 5 RPM.
Affirmative.
Here we go.
And Owen, CPAC would like you to go to auto on MTV again, so it'll stow at the end of the sequence.
Okay. Okay, we're now coming back on step 2.1, driving out 5 millimeters. All ready to grow drop.
Copy.
That azimuth is 180, co-elevation 90.
Thank you. Here comes the drop. It shot right across, Mike, and it touched right from the beginning.
I didn't copy that. Again, please.
Again? Okay, Mike, as soon as the drop started coming out, it's just one big blurb, jumped right across and made contact with the disc.
Do I understand the drop went right across to the rear plate?
Affirmative. Got
Okay,
two big bubbles in it also.
That's very interesting.
Not very good, but interesting.
The best things always are.
I think what we learned from this is we'll have to back it way out and come in real slow with the fluid from the reservoir. We've got a lovely, looks like almost a catenoid in here. Tell John Today his anti-spreading compound works like a trooper. Oh, I filmed a little bit of the filling, Mike, so we've got about, I've used about 200 or 300 frames.
Okay.
And I'm open to suggestions here. You want to go on to rupture?
Affirmative.
Okay, I'm over now on step 2.7, induced instability. I'm ready with 500 frames on the cine camera.
Okay, Byron, we seem to have lost data on the VDU down here, so if you can give us any commentary, it would be appreciated.
Okay, well, I've got two big air bubbles right in the center of the column now. Looks like a pretty good catenoid. It's all the way attached, and it's very stable and symmetric.
Axisymmetric.
Very symmetric. Symmetric. Okay, here we go. I'm starting to withdraw fluid now. My finger is on the camera switch.
Yeah, go ahead, please.
Something causing shock waves in there. I can hear it in the motor.
And CPAC for Owen.
Go ahead, Roger.
Right. Do you have a shutdown?
I have the off-sequence start, and I've been waiting for the FO shutdown to be complete. I did notice that the video disappeared off the monitor, but I've still not got the message FO complete.
Okay, it was running a few seconds behind, so the FO complete should come up right about now.
I think we ought to modify all the procedures to leave the chargers enabled, which is wrong with the Q card and all the other procedures. If you'd check that, please.
We copy. We'll work it.
Okay, I'm Marshall, Space Lab.
Go ahead, Byron.
Roger for 327 Ti.
327.
Okay, Mike. Finally, a zone rupture here, and missed it. It happened really quickly when it came off. It looked like the liquid started to detach from the edges of your... Roger, I don't think we're going to get an FO complete.
Okay.
Spacelab Byron, 327 PI. Your last transmission was unreadable.
Okay, what I said was the final breakage occurred very rapidly. I'm going back to, and I failed to get it on the cine camera, so I'm going back to reestablish the zone, and I'll try it again here.
Okay, that's great.
Roger, we're not going to get an info complete. How would you like to terminate the experiment?
We'd like to give it a couple more minutes, Owen, and then do an IU dep off.
Okay, fine.
That'd just be the nominal off procedure, and then restart the battery charge.
Okay.
Spacelab to Byron, Mike Haynes again.
Roger, go ahead, Mike.
Okay, we have a suggestion down here that those two bubbles in the liquid, if you can avoid retracting them into the reservoir and maybe mop up that liquid and waste it, it might be advantageous for later experiments.
Okay, Roger, understand.
Great.
Let's see when I get it. See when I get it back in contact here. What we get.
And Byron Marshall Ops, you can find chem wipes in 08 Alpha if you need them.
Okay, whereabouts are they in there, Bill? I looked.
They're not wet wipes, they're dry wipes.
Okay, the only I saw was 2 GHF containers and a trash bag. In the trash area?
We're checking.
Okay, Roger, IU dep off. Oh, CPAC.
Go ahead, Owen.
Are you ready for the IU dep off now?
We copy. And Owen, did you get the MTB stowed? And I guess you did the nominal off procedure with DGP and so forth.
Well, I put it back to auto, and I don't really know where the gimbals are, but it returned to some location, and so I presume it was in a proper stow location.
Okay, we didn't have much data. We had it patchy, so we'll have to get playback to see what was happening.
Okay, well, you had nice stars the whole time, and you can see the thruster firing, so that's about all.
Okay, thanks, so.
Mike, it's quiet up here. I'm still trying to get the 2 columns to join up here. Okay, CPAC, you have your battery charge initiated, and it's 0.1 amperes on each charger.
Roger, Owen, sounds good. And what was the time of the start?
14 minutes past.
Roger, 14.
And Space Lab, we've got you for another minute, and we'll see you at about 8 plus 5, 7.
Okay, sounds good, Bill.
And Spacelab to Byron, Mike Haynes, just a quick one.
Go ahead, Mike.
Okay, we have an opportunity to talk in the next AOS, and we're interested in several things. The formation of the drop, bubbles from the reservoir, electrostatic effects, and axial symmetry. So we'll be asking you about those things.
Roger, that sounds okay. Now we've got an axisymmetric drop here. They're finally connected, but we've broken over the anti-spreading barrier. I'm trying to get back to some sort of a semblance of normal here.
Okay, we'll leave you mopping up.
And Byron, don't do any more to the IHF till we get in touch. We have some additional steps for you to run that we've thought about. We're going to run samples in port 1 from now on.
Okay, Mike, I'll be standing by.
Real good. I'll get back to you with details on next AOS.
Okay.
Well, I'm looking at the checklist.
Space Lab 1, this is Marshall Operations. How do you copy?
Hello, Marshall Operations, Space Lab here. Got you loud and clear, Mike.
Loud and clear, you too, Byron. How's everything going out there?
Oh, Michael, I'll tell you, it's like this. This is an interesting phenomenon up here. Mike Haynes around? Marshall, Space Lab?
Yeah, go ahead. We're having some dropouts here, I think.
Okay, we just got another Depth 05 message associated with the ISO activities going on now.
Okay, we can't verify that. Our POCC support is not up at the moment. I will be sure that the... Okay, that's nominal. Mum says that we shouldn't concern ourselves with that. We have a little traffic for you, but first, how about your traffic to us?
Okay, well, I'm working away on Mike Haynes' experiment, and I finally managed to get a drop and get it filmed as a contacted, or almost filmed. The camera takes about a second or two to warm up and get going, so I think we might have missed a little bit of it. Able to induce breakage, which I filmed, and then when I rejoined, got all the liquid cleared up, pulled it out, and got his disc number 5 in position. But when I tried to grow the size drop that he wanted for his second run, it spread all over the anti-spreading barrier on the front plate, over.
Okay, Byron, we copy. It went all over the anti-spread barrier. That's sort of a shame. Look, we've set aside about 15 minutes for you to debrief real thoroughly to Mike Haynes. If I may, I'd like to get a few items up to you and then turn it over to Mike. How would that be?
Okay, that's fine, and I've still got some free time, so it's all set up here, ready to go to try and do whatever he wants to do on this disc number 5. So I'll be standing by. Oh,
real good. Glad you left the thing set up, because I'm sure Mike will have a lot of questions for you. The first thing that I have for you, Byron, is that the MSDR people have decided that the MHF operations, for the time being, only make sense using port 1, that is the left-hand port of the IHF. And they'd like you to please get sample number 312, that's sample 312, installed in port 1, and get that sample initiated. That's done using a DIN IHF 4801, a DIN IHF 1803, and a resume IHF after you have that 312 sample installed in port 1.
Okay, I'll start on it right now.
Thank you very much, Byron.
And Space Lab, this is Marshall Ops. Owen, can you copy?
I think Owen's up in the flight deck for a second. He may not have his radio on. Hold on.
Okay, well, Byron, it's some things that we can give you, but go ahead and do the IHF stuff first and let us know.
Okay, the IHF work is complete, and we've got a steady ISO ops light on now.
Okay, we copy that that's complete, and you got a steady ops light. Okay, we've got 3 little quickies here for you. If you need some wipes, you can find them in Oscar 8 Alpha, Romeo 7 Juliet, or Lima 1 Nancy. Any one of those 3, the wipes can be used for that job.
Okay, good. We got them. Thank you.
Okay, the other thing is that we do have the wrong cable on TVC2. That is an orbital cable, and we'd like to have you change that out. We'd like to have you drag it back into the middeck area when you go off shift. The cable that we want is in Lima 2 Kilo 2.
You copy?
And the other thing, we would like a description on the 101 TV sync problem. If you get a chance, you might go over and look at it. We don't know if you got a horizontal or a vertical problem, or if it's a general TV failure.
Okay, I've got the 101 up. Right now, the tape recorder's at 680. The VTRN up light's been on for the last several hours, and it's off now. Right, it looks like what I call up the dark box. It's very difficult. Almost can get it synced up. It looks like there's a very wide horizontal band, so it looks like it's really a horizontal sync problem.
Okay, is it right
Well, standby.
Is it right in the center of the screen? You just have one horizontal problem?
No, it's a couple of problems together. Using the vertical hold adjustment here, I can get the band up right near the top of the bottom of the screen. And there are some funny sort of diagonal lines occasionally coming across it, and we're not getting a very good picture here.
Okay, Byron.
And I'm not sure, maybe you'd like to try and downlink some TV?
Repeat, Byron.
Roger said maybe you'd like to try and downlink a little bit of this 101 TV if we ever get a proper format for TV downlink.
Okay, that's a good suggestion. We'll look into that, Byron.
Okay, now the housekeeping data I can bring up on the screen okay.
Okay, we copy that you can get the housekeeping data okay.
Okay, I was here when the data take took place, and it's about 1.5 dots, and the VTR in-up light came on.
Okay, we copy that the VTR in-op light came on.
All right, now when I get the TV screen set up and I'm able to display the housekeeping data, and then go back to the dark box, the dark box TV is all fuzzy. I guess it needs a vertical sync, and there's some other funny noise on the screen.
Okay, you appear that you don't have a vertical sync, and there's other noise on the screen we copy.
Roger. Okay, Marshall, we're ready for Mike Haynes again, unless you guys have anything more for me.
We got one more quickie for you. Stand by.
Yeah. Our quick question is this, guys. Have you received instructions on how to operate API in its locks?
Oh, let's see. Hold on. It's not back here in the module now, Mike. Maybe it's up on the teleprinter, and we haven't brought it back yet. The only thing we have is from yesterday.
Yeah, Byron, this would be from yesterday. It's a markup of the usual manual ops checklist. What Steve Mendy has done is to go over the manual ops checklist, pages 8 and 9 of your flight data file, and just line out certain items that have to do with getting things out of the locks in order to allow it to be operated in the locks. And we suspect that that may have been voiced up to the other team, the other crew, sometime yesterday and would be in your flight data file. If it hasn't been marked up, we're just going to send you a teleprinter version of this revision.
Let me check it. Hold on.
Thanks a lot, Byron.
We just got an MSDR crew attention. Let me see what needs to be done over here. Hold on. I don't see anything. See no faults or stops or anything on the CCO. And Mike, would that be under the normal checklist or in the detailed procedures?
We believe it should be page checklist 8 and checklist 9, which is the usual manual ops cue card or manual ops checklist, which are the same thing. It involves Steve crossing out a bunch of lines of text there just to allow operation in the locks. We just wonder if you guys got that or not. If you didn't, we're going to stick something on the teleprinter to you.
Okay, somebody may have copied it down, but it's not in the checklist or on the cue card, over.
Okay, real good, Byron. In that case, we'll get busy with the teleprinter people. As you know, we've had this question about the locks of API, and so all our operations of it are going to be done in the locks. And it's not a very difficult operation, just we want you to have a good, clean copy of the ops checklist as it presently stands. So that'll be coming up in the next few hours.
Okay, I copy that, and that's really too bad. I thought we had it all squared away, that they had it back in, knew what was going on.
Yeah, they did get it back stowed and in there, but because they have to use either the manual stow or the bail stow procedure, management just wasn't happy with that. Kind of a shame, but that's the way it stands. So we're reworking API operation to allow use in the locks. And that's, by the way, not on your shift. It's the oncoming red team that'll be operating this for the first time.
Okay.
And Space Lab, Byron, we're ready to start with the debrief with Mike Haynes. We just want to make sure that before the end of the hour you get the AV recorder 2 change out completed and give us a tape number.
will do. No problem. And okay, 327 PI from the PS2 at Space Lab. How do you read? Over.
327 PI. I read you well.
Okay, Mike. I went ahead and was able to reform the drop on your plate number 1, and able to get it on there. I think I've missed the initial part of the joining because this camera takes a while to come up to speed. I did get the braking on there, cleaned it up, and was going on to run number 2, and I was getting set up with the big drop in plate number 5 when just before the drop was finished building, it spilled out all over the anti-spread barrier.
Okay, we heard that in an earlier conversation. While you were over the horizon, we had a little conference down here, and first of all, I think we'd like to say how much we appreciate your efforts in this first wet run on the FPM. But we have a number of specific questions that I'd like to ask you, and then perhaps you could just give me a filling in on anything else.
Okay.
Okay, the first question concerns the cine camera. Did it function normally, and was it audible? Did you hear it clicking away in its usual fashion?
Sorry, say again, you came in a little broken.
Okay, the first question concerns the functioning of the movie camera. Was it operating normally and audibly?
Okay, in your run it was functioning normally. For the second run of Jan Freiberg, it was straining a little bit, but it seemed to keep working. I was able to see the LED blink on and off, so I think it's reasonably good shape.
Okay, I guess we'll just have to keep watching that from run to run. The next question concerns at the beginning of my run, when you went through the step manually filling the feed tube after you'd installed the reservoir. Was this the stage at which you began noticing ejection of drops from the feed tube?
Roger, that's affirmative. I didn't see the drop come out. I was very careful, and the next thing I knew, I looked back at your plate, and there was a drop of fluid on it.
Okay, in that case, a possible...
Turns out...
In that case, a possible explanation may be sticking of the O-ring in a new reservoir.
Okay, I'm not sure what we could do about that.
Okay, the suggestion here is that when you go through that step with a new reservoir, that you put your hand with a Kim wipe in it over the end of the feed tube and catch any drop that may be ejected.
Very good idea.
Simple, too. Okay, the next questions concern the formation of the drop on the feed plate. Did you notice ejection continuing? Was it still spitting at the other plate during this stage?
Sorry, Mike, try and say it again, please.
Sure. During the formation of the drop on the feed plate, did it continue to eject drops and spit at the opposite plate?
Okay, now you're still coming through broken. Please try again.
Okay, I'll repeat. During the formation of the drop on the feed plate, did you notice that it was still ejecting and spitting drops at the opposite plate, or was it proceeding smoothly and normally at that stage?
Okay, on the second run, as I squirted it out, it seemed to behave normally. What happens when you put the drop out is it doesn't form a little drop at the end. It spreads out over your entire wetted surface, the entire 40-millimeter disc. So it's not clear just exactly when you've got the fluid right there at the edge of the feeding plate.
Okay, Byron, that's good. That's the way that it should behave. Next question. During the formation of the drop, did you notice any departure from spherical shape? Did the drop appear to be conical or non-axisymmetric, for example?
Yes, right in the beginning, when the drop first started forming, it came out conically. It was really pretty much pointed at the end.
Okay, that's of major interest, and maybe we can watch out for that in future runs as well. The next question concerns the advance to contact stage of the run. Did this proceed normally once you'd formed a drop?
Go ahead. What's your question about the advance to contact stage?
Okay, Byron, the question is, did the advance to contact proceed normally? Did the, once you'd formed a part spherical drop, were you able to advance it towards the other plate without anything unexpected happening?
What That's affirmative. Yes, I was. I was able to get it to come up right close, and it seemed to spread just about the time it touched. There was very little time waiting to push the air out of the way. Over.
Okay, Byron, that's great. Now, the next question concerns the bubbles which you noticed. Can I ask you how many they were, how large they were, and when in the drop formation they appeared?
Okay, there were two, and they were about 5 to 6 millimeters in diameter, and they came out right near the beginning of the first droplet formation.
Understood. Two large drops right at the beginning of the drop formation. Next question.
Confirm.
Okay, the next question concerns this transgression of the anti-spread barrier. Did this occur on the feed plate? I understand it did in the second run. And did it spread over the edge of the spreading disc as well?
No, it just went over the anti-spread barrier. It did not spread out over the entire edge of the disc of the, the entire, what is it, maybe a 10-centimeter disc?
Could you say again? I didn't quite copy that.
Roger, when the drop spread out over the anti-spread, go around the edge of the disc. It stayed on the major part of the disc, but it did go well beyond the 40 millimeters.
Understood. It went well beyond the 40 millimeters. Almost a final question. During the recovery phase, were you able to complete this successfully without withdrawing the bubbles back into the reservoir?
Roger, the bubbles went somewhere. I'm not sure. They finally coalesced and must have migrated to the surface because I didn't see them as I withdrew the liquid. When reformed the drop the second time, I did not see any bubbles in it.
Byron, that was broken after the drop, after the bubble migrated to the surface of the drop. Could you just repeat the next sentence?
Roger, the second drop that I formed, I did not see bubbles. Negative bubbles.
Understood. No bubbles in the second drop. Okay, the final question from me.
Right.
The final question from me is specific to my experiment. You mentioned at the beginning that you noticed that 3 of the spreading discs had a sintered appearance. Did I read you correctly? Sintered?
Roger. The one disc, I guess it's disc number 5, has a sintered appearance on it. It is not smooth like the other 4 or 5.
Okay, I understand. Disc number 5 has a textured appearance on the surface. It may be interesting to get some spreading data on that disc later on. There's a question here.
Sorry, say again?
I understand that disc number 5 has a textured appearance on its surface, and it may be interesting, therefore, to study spreading on that disc when you get the opportunity.
Okay, well, that's the disc that's in there now, and I'm ready to go. Unfortunately, it has the very first drop. What I'd like to do is I've got a little bit of time to go run one more run of your experiment, but I want to know what size drop and what numbers you'd like to use. Cannot reach the large size bubble that you had for your second run.
Okay, Byron, I'll come back to you with some numbers on that in a couple of minutes. Just give me time to work on it. Meantime, can I ask you a question from Mel? We have no data down here. Did you get the 312C experiment started in the IHF?
Yes, I got the 312 experiment, and I used, 4801 and 1803, whatever those numbers are.
4801, 1803, we copy. Thank you. I'll come back in just a couple of minutes with numbers for the extra run. Thank you very, very much indeed, Byron.
Okay, roger. Thanks, Tom. Good space lab.
Space Lab for Byron, Mike Haynes.
Hey, go ahead, Mike.
Okay, Byron, we have some numbers for you for this run on 327. The front plate position that you drive towards should be 29.9.
Okay, I've got a front plate position of 29.9.
Affirmative, and a reservoir position of 27.7.
So 27.7?
Affirmative. This should grow you a hemispherical drop. Having grown the drop, then the advance to contact positions corresponding to step 2.3 in the procedure, the positions are 19.9 and 17.7.
Okay, copy.
Okay, that should form you a nice hemispherical drop which ought not to spread over the barrier. I have one more question concerning the spreading over the barrier on the feed plate. Can you give me some estimate? Byron, can you give me some estimate of the angle formed by the drop at the edge of the 40mm disc when spreading took place, when it transgressed the barrier?
That's pretty hard, Mike. I think it was somewhat more than 90 degrees. So I'm not sure. I really wasn't expecting it to spread, and I was just kind of keeping an eye on it, and all of a sudden it went bloop, right on over.
No, I feel. Okay, somewhat more than 90 degrees. That's reassuring anyway. Thanks a lot, Byron.
Roger. Now, if we have the other MSDR people around here, we have taken the bad sample flange in the IHF, and Ulf was able to unscrew the bracket around the LEMO to be able to reposition it. So I think we might be able to reposition the connector in the good flange also.
Okay, I think Mel copied that.
Okay, we'll stand by on that one.
And Byron, this is Marshal Ops. How did you turn that flange?
Okay, Ulf took a pair of pliers and went in the back side of it, and there's it's like a just a small nut in there, and he's able to loosen that and readjust the position of the LEMO connector over.
Were you able to then turn the nut back up?
Affirmative.
Okay, we copy affirmative. Thank you very much.
Okay, now he hasn't done it on the flight. The other one is still in the port number 2s, but it looks like it's possible to do it here.
Okay, and the PI thanks you for that, Byron.
Okay, well, we're trying to do what we can rather than just give up on half the sample.
Yeah, we copy. Thank you very much. And Byron, when you get a chance, the 102 PI would like to have you do an ARU linear calibration.
Another one?
And Mum called that caused the memory management 06 error, so disregard.
Okay.
And do you need a procedure and page number on the linear cal and the ARU?
We just did it when I came in 2 days ago. They want me to do it again?
That's affirmative.
Okay, no, I don't need a page number. I'll get it later.
Roger.
Hey, Bill, this is Ulf speaking. How do you read me?
We copy Ulf.
Could you connect me to the 300 system people?
Ulf, we can't copy you. You're too much hiss on the line.
Is that any better?
It's a little better.
Okay, I'm using the master communication station, and it's probably not as good as a headset. My question is whether I could talk to the 300 systems people.
You want to talk to 300 systems?
That's a firm.
Okay, stand by.
And 327 PI from the PS2.
And Ulf, Jurgen will be on the line here in 1 minute.
Thank you. Marshal Ops at BS2.
Go ahead, Byron.
Okay, comment for 327 PI, Mike Haynes. I put in his next settings, but there's only a difference of 2.2 millimeters, and it was just barely enough to coat the front surface of the 40 millimeter disc. So I still don't have a bubble here. Maybe we should go back and use the numbers that I used for his first run.
And Space Lab Marshal Ops for Ulf, Jurgen is on the line.
Copy that. 300 systems, this is PS1.
Hello, Ulf. This is Jürgen.
Yeah, Jürgen.
Go ahead.
I have a suggestion. I tried to correct that problem on the isothermal heating facility, and I used the flange which presently has a leak. And I'm able to turn that LEMO connector to any position, and I think we should do the same thing for the other one.
Can you repeat, please? It's too crowded here.
Stand by a second.
Yeah.
Okay, Jürgen, can you read me? 300 system, this is
Ulf.
PS1, how do you read?
Ulf, I can hear you.
Okay, now, listen, we took the old, the sample flange, the flange connector, which has presently a leak, and tried whether we could reorient the LEMO connector. And I was able, with a little pair of pliers, to loosen from the backside the screw of the LEMO connector, and now I'm able to turn it around, and I'm also able to make it tight again. And I think we should do the same thing with the flange we are presently using for port 2 in order to use the second side of the isothermal heating facility.
Okay, Ulf, I understood what you have done. That what I want to propose to do to try on the old sample flange. The problem is just if this doesn't work, and if you are not going to do it very properly on the good flange, then we are losing everything. Over.
Okay.
Just stand
Okay,
by.
do we have...
Go ahead.
Okay, I understand your concern. Maybe we can then try the old flange, the ones which had the leak, and see whether that works now.
Ulf, just listen. The problem is not the ceiling, but it's the feed-through itself.
Okay, so you think that would not fix it if I tighten that strut inside the flange?
Please, Ulf, wait for a decision here from the ground. This is a science. The scientific guys have to make their decision. We have to wait for them.
But I mean...
That's a solution I would propose to do for you, but we have first to wait for a decision from the science people. The problem
one additional...
Say again?
Okay, I'd like to ask you one other question.
Yeah.
Do we have a spare feed-through?
No, no, no.
Okay, other question is, can we make the cables a little longer, the blue cables which come off the front plate, such that we could put the connector in a different position?
For this, you have to open on your right side in front of the front panel, IHF front panel, these both screws, and then move both parts from the harness clamping device backwards inside the rack, and then open the 4 screws for the harnesses, that the harness comes loose. Then you can try to remove a little bit the harness. You understood?
Yeah. We'll see what we can do. If we gain about a centimeter length, then we could use the system as it is now.
Yes, that's true. But you have to open on your right side this clamping device.
Okay, we'll try that immediately.
Okay, go ahead.
Marshal out, stay pod.
Go ahead, Byron.
You got 0-0 and an MMU. You guys playing with them down there?
That's Mom. Just disregard that,
Give us an
Byron.
idea ahead of time, okay?
Okay, sorry about that.
Space Lab for Byron, if you're there.
Byron, we need you to start on the AV tape recorder change out.
That's been in work, Bill, and I'm just about halfway through it. I'm standing by. What I've done for Mike Haynes is to grow the same size drop as his first run, and it was sitting there. Must have spread out over the anti-spread by now.
Okay, if you can just do
Yeah,
this.
it was a very...
If you can do both, just continue, Byron, with your conversation.
Okay, yeah, no, I was telling Mike that there was a lovely drop sitting there, and now I came back and it's spread out all over the 40-millimeter disc, all over the anti-spread and everything. And it was a very small one. I'd say the contact angle was about 40 degrees.
Okay, Byron, I copied that, Mike Haynes. I think we'll have to withdraw the Kodak patent on the anti-spread barrier.
And Space Lab, we've got you for 2 more minutes. And we'll see you at about 10.
Very good.
We have you for 2 more minutes, Byron, and we'll see you at 10 plus 32.
Okay, Bill, just for your info, the tape that's coming off of VTR number 2 will have the number 6. It'll be the number 6 tape, and it had about 17 minutes of tape remaining on the end of it.
Roger, we copy. Thank you, Byron.
And Byron, if you have a chance to take a picture of that spreading drop, we'd appreciate it.
Okay, will do, Mike, and I'll see what I can do about it.
Many thanks.
And before we lose you, Byron, is Owen's SAL operation proceeding satisfactorily?
Affirmative. He's right in the middle of it.
Okay, we copy.
Owen, says that he's down to the 0.02 bars.
Okay, we copy. 0.02 bars.
Okay, he says the light's on now, so it's all okay.
Okay, we copy. The lights are on.
And break Space Lab for Ulf. This is Robo. Okay, then in the blind, Ulf, what we were talking about is the 2 little screws which are on the panel in between the 2 wires which come out of the IHF panel. If you loosen those screws, that allows the clamping parts to go backward. And if they are loosened up, then they will go out of each other and loosen up the cable. Over.
Willow, can you try and say again? We copied just only half your transmission.
What we're talking about is the 2 screws which are in between the 2 blue cables. They should be loosened, and then you can get the clamp backward.
300 ops. Sorry, 300 support.
Space Lab Marshall, we're AOS for 52 minutes, and good morning to the Red Crew.
And Space Lab Marshall Ops, also good morning from WUWO. Is Byron still there? I have 2 questions for him.
No, he has left the module. He's in the mid-deck. Marshall Ops, this is PS1.
Go ahead, Ulf.
Okay, at mission elapsed time 10 hours, 30 minutes. We put in sample 317 in the GHF and hit the resume.
Roger, 317 GHF and resume.
That's a firm.
And Ulf, probably you could relay the 2 questions which I had for Byron.
Okay, what can I do for you, Hugo?
Okay, the 2 questions. Well, first is on experiment 28, whether the tape change was done and whether the exercise was good enough for a heart rate of 120. And question second is the question was for a ARU calibration. The reason is that the drift is supposed to be larger than expected. And the question is whether Byron understood that he had to do those calibrations on both ARUs and reset them to 0. Over.
Yes, Byron did the calibration of both ARUs. And 28, whether there are fresh tapes in it. But I don't know what the heart rate was when they did the experiment.
We copied Ulf, and if you get a chance to ask him, relay the answers for us. And also, we have a question, of course, on what happened with the isothermal heating facility. Over.
Say again the last sentence. What happened? What?
with the isothermal heating facility. Over.
Okay, the isothermal heating facility is now ready for sample change, and we have the port 2 unlock light on, and I pulled out the cable about 15 millimeters, and I will now try whether I can connect the connector to the feed-through.
Sounds good. Off, over.
Did you copy, Wupo?
That's affirmative, Wolf. We did copy. You have the cable lengthened a little bit, and we'll try whether you can make a cable connect and on the same time get the flange in port 2 in. Over.
Okay, and if that doesn't work, then I ask for authorization to reposition the LEMO connector in the flange.
We copied, Wolf, and as you know, we stand there on waiting for a decision on that, so don't change the flange position yet. Over.
Okay, roger that.
And Ulf, if Bob is handy, we've got some daily planning info for him.
Yeah, I'm handy. Okay.
Okay, Bob, just a few updates to your PCAP starting on page 17. Hour 17.
Wait till I get there.
Okay, in Space Lab, for Ulf, the 300 ops has decided that we should not go ahead with trying to change the position of the feed-through in the flange. So the longer cable should work, and if it doesn't work, we're going to continue only with one chamber. Over.
Okay, copy. But I'd like to let him know that we need about 20 millimeter extra cable length to install the connector, and I will do my best. But anyway, there will be some torque on the LEMO, the position it has now, at the position it has now.
We copied, Ulf.
Okay, at POCC, I'm at hour 17 on the PCAP.
Okay, Bob, on the 101 activity for Ulf, we're extending that to 1731, 17 plus 31. And we're including replanning requests 101-001 and 002, which should be on your teleprinter as message 22, message 22 on the TPR.
Those have to do with cutting up the plants and putting them in the vials, right?
That's affirm, and in conjunction with that, you can put the samples on the workbench, and the blue crew will put them in the freezer simultaneously with the blood at 2 days, 23 hours.
Okay.
Okay, then...
Okay, we copy that.
All right, then hour 19, 19er.
There.
Upper right-hand corner, minimum ECAS is now 10.060.
Okay, got that.
All right, then the only other thing is that you should also have a replanning change summary on the teleprinter, message number 23 alpha, which was sent at 2 days, 6 hours. Just for info.
23 alpha?
That's firm. And that's all we got right now.
Okay, and let me see if I understand our situation. It looks like Route 21 has fixed itself, or we've worked around it. Is that correct?
That's firm.
It looks like we're going to give up on the 201 VTP.
Stand by on that one, Bob.
Bob, the latest we heard on the VTP was that we're not going to try to fix it. Probably the head is dirty, which we cannot really clean, and therefore we plan around it. The next experiments on 201 will be done without the VTP as it stands right now. Over.
Okay. And AEPI, we're not going to take it out of the locks, huh?
That's the way it stands now, Bob. And then Space Lab for Ulf. The 300 ops asks you the following. As you understand, do not try to rotate the feed-through in the flange, but you could possibly, without any torque, try to rotate the connector on the cable. Over.
No, that's not possible, because we have to install the cable almost in the 12 o'clock position now. And that means there is a torque in a clockwise direction on the LEMO connector.
Yes, Ulf, I do understand. It was just a matter of that sometimes the connector at the cable can be rotated with a little torque. But if you try it, just put only a very little torque on it. Over.
I will do my best. Marshal Ops, this is PS1. I have the port 2 of the ice assembly heating facility open now, and I'd like to know what sample I'm supposed to process in that one.
Stand by, Ulf. You get that. And Space Lab, Marshal Ops for Ulf. Just try first whether you can run at all with port 2 closed and the cable connect without any sample at all. So don't put a sample in there at the moment.
Let me first try whether I can connect the connector.
Roger.
Marshal Ops, by pulling out the cable, we were able to connect the LEMO connector into the port 2 feed-through.
Sounds excellent, Ulf, and stand by for a remark from 300 ops. And Space Lab for Ulf, that sounds really good that you have port 2 connected. You can put in a sample, which is 313 alpha, over.
313 Papa or Alpha?
Alpha, 313 alpha, over.
313 Alpha, okay, thank you.
That's affirmative.
POCC Space Lab.
Go ahead, Bob.
I'm still interested in talking to Byron.
Yeah, if he's available, Wilbo's got a question or two for him.
Okay, yeah. Hello, Marshal Ops, PS2 here, go ahead.
Okay, Byron, I hear you loud and clear. I had two questions. One is on experiment 28. First question on experiment 28 is whether you performed a tape change. Second question is whether the exercise you do with one bungee is appropriate to get your heart rate up to about 120. Over.
Okay, was your first question on the tape change?
Whether you performed a tape change. Over.
Negative, I did not. The tape still is over half full, Wolf.
Understand, you did not change the tape, and the tape was still half full. And what about exercise? Over.
Okay, the tape was over half full, so I did not change it. Secondly, it's difficult. I don't think I got my heart rate up to 120. I probably went up to maybe 100 or so, but that's about the best I could do.
Okay, we copied Byron, and then I had another question. About a little over an hour ago, a question came to do a new ARU calibration on both ARUs because we expect a larger drift than expected on the accelerometers. Did you copy that? Over.
Roger, I copied it, and I have not performed it yet. We'll do that before we go to bed.
We copy that, Roger, and over and out.
Okay, thanks, Rubo. We'll talk to you later. We'll get some chow, and I'll be back in a little bit.
Space Lab Marshal Ops for Wolf.
Yeah, this is Wolf.
Yes, Wolf. On the IHF, you started the GHF a little early. Therefore, it will take some time to pump down the IHF. We expect to know by about 11:25 whether or not the port 2 is successful. Over.
Okay, roger that.
And Space Lab for Ulf, but you can go ahead to do a resume IHF. Over. Space Lab Marshal Ops for Ulf, please go ahead then and do a resume IHF. Over.
Yeah, wait a minute. I'm trying to find the numbers for the IHF. See, what I should do here is data in IHF and 3333, enter, and data in IHF. Second entry is data in IHF, 1252, enter, and after that, resume IHF. Confirm that, please.
Yes, Ulf, that's confirmed. Your numbers are correct. Over.
Okay, thank you. Okay, Marshal Ops, this is mission elapsed time 10 hours and 57 minutes, and that was the resume of the IHF for sample number 313 Alpha, which is in port 2.
Yes, Ulf, Marshal, we copied and it's confirmed that that is correct. Over.
Roger.
Space Lab Marshall for Bob.
Go ahead, PSEC.
Bob, we've got a couple things for you here, if you're not too busy.
Never too busy to help out.
Well, that's good. We know that. We'd like to know, we're a little anxious to know at this point, how many orbiter tape recorder cassettes have been used. And in conjunction with that, we'd like you to be advised that you may now put discretionary TV on the orbiter tape recorder per the guidelines coordinated pre-mission. And if you would, make sure that Owen understands that, because he's certainly going to be interested in hearing it.
Oh, yeah, I think I'll keep that a secret from Owen. The rest of us will use it for our own purposes.
Okay.
Okay, I will check with them upstairs and let you know about the numbers, and I'll also tell them what's going on.
Roger, thank you.
Marshal Ops, this is PS1.
Go ahead.
Okay, can you check what IHF samples have been processed so far?
Stand by, all. Space Lab Marshall for Ulf.
Marshal, go ahead.
Okay, Ulf, answer to your question on the IHF samples which have been processed so far. We have processed 311 Alpha, 312 Charlie, and in the furnace now is 330 Alpha.
That's not correct. In the furnace is 310 Alpha.
That's affirmative, Ulf.
Correction, 313 Alpha.
313 Alpha.
Affirm.
Roger. And Space Lab Marshall, we confirm battery termination down here on CPAC, battery charge termination.
Okay, we just got a depth 05 message.
Roger, we see it.
Marshal Ops, just for curiosity, can you confirm that the internal pointer of the MSDR is now pointing to the GHF Ionivac? And the pressure is somewhat like 6 times 10 to the minus third, 6 times 10 to the minus 4 torr.
And Ulf, that's fine. We confirm that. And for Bob, the depth 05 message evidently came from ISO turning their experiment on by direct ground command.
Yeah, we see the ISO lights on.
We'll ignore it.
Roger.
Space Lab, this is Marshal Ops for Ulf, if you're ready to copy.
Marshal Ops, stand by a second. Marshal Ops, PS1, I'm ready.
Okay, Ulf, there has been a teleprinted printer up, and that is on experiment 003, OCR number 6, which ask you to replace the scheduled FO, which is 4 Bravo, by Limp Glow, which is 4 Charlie. And that is for FO runs 5, 6, 7, and 8. And you will find the operation procedures to be on the page Charlie Lima -8 and -9. In addition, sometimes it could that the shutter light does not come on in the open position in step 12. If that is the case, then add to step 17 if the filter is 6300 and high voltage is 2, turn on calibration. Over.
Okay, I copied the following. It relates to experiment 003, and you asked to replace FO4B by FO4 Charlie. And the procedure pages is Charlie Lima -8 and 9. And there was one thing with the shuttle light does not come on, and didn't copy the rest of it.
Yes, Marshal, for Ulf, on the shutter light, if the shutter light does not come on in step 12, 1, 2, then proceed. Also, add to step 17, if filter is 6300 and high voltage is 2, turn on calibration light. Over.
Okay, in step 17, if filter is 6300 and high voltage is 2, turn on calibration light.
Read back correct, and in addition, do not try to close the shutter. Over.
Do not close the shutter. And what time will it be when we run EPI?
Okay, Ulf, stand by on that question and confirm when you found the teleprinter uplink. Over.
Okay, I'll take a look. When did it come up? Already a long time ago or in recent time?
Just very recently, Ulf, and it should be message number 27.
Okay, let me go find it.
And POCC, I'll trust you see the 01 message, timeout 48 message.
Roger, 3+16. Thank you. And Bob, looks like they were late on their commanding for that one, and that's why you got the 01 message timeout. Good call, thank you.
Okay.
Space Lab Marshal for Ulf.
Marshal?
Ulf, we're noticing that experiment 20 is not operating, and we think there are two possibilities for this. One of them is that the DC utility breaker on panel Romeo 4 Victor is not on, and if that's not the problem, then we suspect perhaps the cable, the data cable in the airlock is not connected, but we'd like you to check the DC utility breaker on R4V and verify that it is on for experiment 20.
That is checked and on.
Roger, thank you.
And I picked up message 27 from the teleprinter.
Roger. PCF 69, Roger. And Ulf, Space Lab Marshal for Bob, we need a PCF 69, which is not in the procedure for this run. And 69 equals 0.
Okay, you want 69 to go 0?
Affirm. Go ahead. And Ulf, be advised that the flange fix was successful for the MSDR. Good show, and you get an attaboy.
Okay, that's good news.
And Ulf, back to the experiment 20 question. When you have time, we'd like you to reset that breaker, turn it off, and then back on again.
Okay, it didn't work. It's off. Back on.
Thank you. And thank you for the PCF, Bob. And Space Lab Marshal, we've got about a minute before LOS for whoever is available. If you have a chance, we'd like you to pan the TV camera 1 to the right in order to cover Ulf at the fluid physics area so that we can get good coverage of him real time at 2 days, 12 hours, 51 minutes. Just pan right slightly to cover Ulf at the fluid physics module.
TV 1 to the right.
Yeah, we set that up early just to get the 101 stuff. We can move it back. Now, when are you going to get that? Do you want us to record that stuff, or are you guys going to get that real time when you come back up with us?
Stand by. Real time, Bob. Yeah, you don't really need to move the location of the camera, Bob. Just point it toward the right slightly. And we'll see you again at 12 plus 12 plus 08. 12 plus 08. Space Lab Marshall, we're AOS for 41 minutes.
Marshall, this is Space Lab. Nice to hear you.
Yeah, nice to hear you, Ulf. Just a reminder to you for 19 Alpha in support of CPAC. And Ulf, if you have a minute, and if it's not already pointed at the right direction, we would like TV camera number 1 aimed at API, aimed at the API panel, if it's not already there, please. And don't forget 19 Alpha.
Okay, I'll do that.
Roger, and we're expecting real-time video at 12 plus 15. We'll let you know when we got it.
Marshall, just for clarification, what TV...
And Ulf, we've got our comm back now, and did you have a question for us, please?
Ulf wanted to know what particular TV setup that was.
The position, the mounting position, Bob, is as it exists now, and I believe that was for TV 10. We just like it panned so it's pointed at AEPI.
Okay, a little on schedule, unplanned TV, in other words, right?
That's firm.
You're going to get that real time. What are you going to do about the MTV from CPAC in real time as well?
Yeah, the MTV is scheduled on its real-time PCAP of 12:15, I believe, and the other one is for 12:51 on a dump.
Oh, the stuff at the AEPI panel is for later on, huh?
That's a firm. We want the MTV during the run.
When are you going to take the analog from, okay, the MTV you watch during the run, the analog is going to go on AV2, and that's what you're going to dump post-run, I gather, but what are you going to do with this TV from, of AEPI panel?
Yeah, looking for general coverage in the module of the 2 crewmen working, Bob. It's PAO.
Okay, but what's it going on? It's not coming down real time, and it's not going on AV2, and no one's asked us to put it on AV1.
It's a real-time post-dump of the AV2. So we want it on AV2 during the run.
Okay, but right now my PCAP tells me to put O2 analog on AV2.
Roger, Bob. That's affirmative, and we'll configure it from the ground at the appropriate time.
All right. I won't worry about it.
Roger.
CPAC for Bob.
Go ahead, CPAC.
Roger, Bob. We'd like to do MTV enable any time now.
It is. TV is enabled, and its system is in auto.
Roger that. And the EBA heater looks good, Bob.
Hey, thank you.
Space Lab Marshall, you can ignore any experiment 20 error messages.
Again, about experiment 20, we don't see any error messages for 20.
Yeah, if you get any, you can ignore them.
Okay.
And we see the beam, Bob.
Good. I think I'm the only one in the whole vehicle who's not allowed to look at the beams. Everybody else is at the windows.
Sorry about that.
Space Lab Marshal for Ulf, we notice we don't see 19A running, and if you haven't done so already, we'd like you to start 19 Alpha.
Bye.
Procedures 19A/Foxtrot 100.
That got lost over in the comment section rather than the other section where we were looking for things. Based upon the...
Space Lab Marshal, be advised, CPAC says they're seeing Space Lab charging up to a kilovolt.
Okay.
And Bob, it looked like we had a thruster firing just then.
We went to free drift to Swallow. I'll check with John.
The MTV is showing thruster firings.
The commander says it's a Big 10-4. We've been in free drift for some time.
And we copy 19 running, Bob. Thank you.
Go. Okay. FPOCC, we just got another ISO depth 05 message.
Roger, ISO depth 05. We see it too.
And Bob, this is CPAC. Looks like what we're seeing is the beam firing. It looks a lot like thruster firings. We're at 200 milliamps right now, 5 kilovolts.
Okay.
And Bob, this is CPAC. When we come towards daylight, we're going to want to do an MTV manual ops turn off using step 4 in the checklist, 02 Delta Tango 18.
Okay, it looks to us up here as though we will still be in darkness at 35, which should be at the point that it turns it off. Is that not correct?
And Space Lab Marshal for Ulf on 19 Alpha. Ulf, we'd like you to modify the upper energy level from 6.3 to 3.0, please.
On 19 Alpha, upper energy level from 6.3 to 3.0.
That's affirm.
Okay, so CPAC, you want me to go do, basically just do a manual, an MTV inhibit, right, at sunrise?
That's affirmative.
Right. Okay, I think that's right, too.
And Space Lab
We lost all the electrons here.
Right, still easy.
The message for Ulf, we see the energy level at 30, and we're happy with that, Ulf. Thank you.
Okay. I'm absolutely fascinated how much fluctuation these electrons have. Sometimes there's nothing and sometimes there's a lot of intensity.
Copy that.
Just fine. We're 107 seconds from finishing.
And CPAC for Space Lab, the changes you see are perhaps from different currents and different voltages that we're emitting, where the remainder of our pulses are at 300 milliamps. And CPAC for Space Lab, thank you very much. It went great. The charging looks very interesting. The MTV photos showing the glow is going to keep us busy for some time.
Marshal Ops, this is PS1. Is that good enough for 19?
Ulf, we'd like you to go to energy step 8 and upper energy level back to 6.3.
Okay.
Okay, Ulf, we're happy with that. Thank you, sir.
And CPAC for Bob, you're going to do our manual ops turn off of MTV?
Say again?
We'd like you to go ahead and do the manual op turn off of MTV, step 4 on the checklist 02 Delta Tango 18.
I just went to manual and inhibit. All right, I'll do the rest of it.
We don't have electrons left here. They're all gone.
CPAC, you want me to leave MTV and inhibit or enable?
You'll have to put it in enable in order to do the manual ops turn off and then back to inhibit.
Well, the procedure on 18 has me start off with it in inhibit.
And Space Lab, Marshall, good job from everybody. And for you, Bob and Ulf, the mom is going to hold the master as soon as he can and implement a replanned timeline. So he'll be changing out the master. Don't be alarmed.
But coming back to this, the procedure on page 18 has MTV starting out in inhibit on step 2. And then step 4, we do all the actions, which I did. And step 5 has you put it back to enable. Is that what you wanted?
Yeah, Bob, we needed enable just to do step 4 and then back to inhibit. We understand. And we need enable, step 4, inhibit.
Okay, I'm going back to inhibit on it then.
Roger.
Marshal Ops, this is PS1.
Go ahead, Ulf.
Okay, is 19 happy with the information he got? Right now there is no electron flux visible.
They're very happy, Ulf. Thank you very much. Compliments from the 19A guys.
Okay, we take it out then.
And Space Lab Marshall, timeline work is finished, and it's counting. Thank you.
Okay.
We see that.
And Bob, we confirm the shutdown of the MTV.
Confirm shutdown MTV, thank you.
Roger, Bob. Thank you very much.
And Space Lab Marshall, Experiment 1 is commanding from the ground. There's a slight possibility of a Depot 5 or an 01 message timeout. You can ignore both if you see them.
Okay, copy that.
Ops, this is Space Lab.
Go ahead, Ulf.
We have an HTT ops lamp flashing at the MSCL.
Roger, HTT off. Stand by. HTT ops light, thank you.
That is correct. HTT ops lamp blinking.
Ulf, we're expecting that to happen, and they're happy with that, and start the next HTT run at the scheduled time per PCAP.
Okay, I'm ready with EPI here.
Copy.
Next thing to do is DEP update and ephemeris update.
POCC, Space Up.
Go ahead, Bob.
Yeah, you guys don't think you'd be willing to let us run Appy out of the locks and up and back in primary one more time to just see if it wasn't a sequencing problem that gave us, you know, something out of sequence the other day?
Stand by. That's a negative, Bob. We're working on it, but not for this one.
Okay.
POCC, this is PS1.
Go ahead, Ulf.
Just for confirmation, the EPI people want me to do that DEP update and also the ephemeris update. Is that correct?
I will verify that, Ulf, and just a question whether you have this teletype message teletype message number 18 alpha to for some changes on the EPI.
Miss that, say again,
You got a message up the teleprinter on this performance for API. The number is 18 alpha. I just want to confirm that, over.
Okay, let me check that. Will we have a message 110 alpha, but not 18 alpha?
Stand by, Ulf, we're just checking here.
The message number is 010 alpha. That's the only one we have. And the message 27.
Okay, Ulf, as far as we know, the 18 alpha was uplinked yesterday at 01 day and then 20 hours. Over.
Okay, roger that. But what do you want me to do? My simple question was, do you want me to do the DEP update and the ephemeris update?
Okay, Ulf, what I'm going to do here, I have a copy of the message and going to read you through it.
Okay, stand by until I have something to copy.
Space Lab Marshal, we're about to go for real-time TV and would like a confirmation that you guys are ready for that.
Confirmed. We have the television set up.
Okay, thank you.
And we have an 01 command FO2 and a DEP 00 command. I assume that those are all parts and parcel of 01.
Marshal Ops, I'm ready to copy.
Stand by, Ulf.
And if we got a good video down here in the POC.
And Space Lab for Ulf, what we're going to do is, instead of the DEP update, we're going to have a modified DEP checkout procedure. Over.
Okay, go ahead.
This is on page checklist dash 3, and follow steps 1 through 10, then modify step 11, ignore original check of current values, and add the following. Allow camera to operate in the locks, do an item 6, 004151, check current 000402. Item 7, 000401. Item 8, and check a current value of 000401. Over.
Okay. You want me to go on page 3, stand by. Okay, perform steps 1 to 10, and then go to step 11, but ignore the current values, and give an item 6-00451, and check 00451. Item 7-00401. Item 8-00401.
Read back correct, Ulf, except item 6 is 004151, and then after that check current value being 000402. Over.
Okay, item 6-00451, and check current value 00402.
Roger, current value starts with 3 leading zeros. Over.
So it is 000402.
Yeah, read back correct. And then after you've done this modified step 11, we go to an ephemeris update, which is on page detailed -8. Follow step 10 through 15, 1-5, and use ephemeris for day 2.
Slowly. Breathe. Okay, after that, go to ephemeris update, which is on page detailed -10 or 8. I did not copy that.
Oh, that's on 8, and then follow steps 10 through 1-5. Over.
Do steps 10 until step 1-5.
And Ulf, use ephemeris values for day 2. Over.
Ephemeris values for day 2.
Okay, Ulf, and after you've done that, then we return to the depth checkout on page CL-3 and follow step 13 through 18, and that completes this message.
After that, go back to depth checkout, page Charlie Lima-3, and do steps 13 till 18.
Read back correct. And Space Lab Martial Ops for Ulf, we got a correction here. The last number 18 should be 15. It's 13 through 15. Over.
Okay, on page 8, steps 13 until 15. Is that it?
Yes, read back correct. Oh.
Slowly. Breathe. Okay, after that, go to ephemeris update, which is on page detailed -10 or 8. I did not copy that.
Oh, that's on 8, and then follow steps 10 through 15. Over.
Do steps 10 until step 15.
And Ulf, use ephemeris values for day 2. Over.
Ephemeris values for day 2.
Okay, Ulf, and after you've done that, then we return to the depth checkout on page CL-3 and follow step 13 through 18, and that completes this message.
After that, go back to depth checkout, page Charlie Lima -3, and do steps 13 till 18.
Read back correct. And Space Lab Marshal Ops for Ulf, we got a correction here. The last number 18 should be 15. It's 13 through 15, over.
Okay, on page 8, steps 13 until 15. Is that it?
Yes, read back correct. Space Lab, this is Marshal Ops for Bob.
Ready to go?
Yes, Bob, request from CPAC to have no SMO on Model 5 and Model 6, correction, Model 7, but that after Model 7 complete, you immediately start with the SMO, which actually is on Model 6. But the request is to have the SMO immediately after 7 complete, which is still in the dark. Over.
Okay, let me go through that one more time. You want no SMO for Model 05. You want no SMO for Model 07. But you want me to do a SMO between 7 and 6?
Yeah, that's affirmative. And immediately after 7 complete, which is still in the dark. Over.
Alright. Any particular SMO they want?
And Space Lab Marshal, just a reminder, we've got 2 teleprinter messages up there that you'd be interested in. One of them is message 17. That's the AEPI contamination run. And another one is message 27, changes in the API procedure for 03 manual ops.
Marshal Ops, this is CS1, so again.
Just a reminder of 2 teleprinter messages, which should be up there now. Message 17, which is for AEPI contamination run. Message 27, changes to AEPI manual ops procedure.
Yes. The message 27, but I haven't...
Okay, we had a little comm drop out there, Ulf, but I think we copied that you received message 27, but you have not found 17. Is that affirmed?
I'm missing message 17. We'll take a look at it.
Okay, we understand it was uplink yesterday, about the middle of the day.
Okay, we'll check it.
And Space Lab Marshal, for Ulf, just a reminder, your go for experiment 314 in the IHF at this time, and for whoever can do it, we'd like the cameras turned off after we go LOS, which will be in about 3 minutes.
Again, sample number, please, Marshal.
Space Lab Marshal, Ulf, did you copy that last?
Say again the sample number, please.
314, sample 314.
Okay,
Okay, copy at this time.
Okay, thank you. And we'd like, Bob, if you've got a minute to call up DPM and check the state of the CPAC DEP, which is SID 4665. It should be should be operational. We think we've got a procedural problem to work. If you do that for us, we'll get busy on it.
CPAC is showing NOPT, and I wonder if that happened when I turned the IUDEP off.
Stand by.
My recollection is I got a DEP message at the time, which I just presumed was a ISO message. Look at the fault summary page, you can see that I had an FO complete. And then we got the 001 command problem, and then there were two DEP messages, a DEP 00 and a DEP 12.
Roger, we see him too. Okay, Bob, we agree, and we think it's a procedure which we'll get up to you as soon as we get it, and we'd like you to opt the DEP, please.
Okay, it works.
And Bob, for this next run of CPAC, just prior to the beginning of Model 5 in the dark, we'd like you to enable the MTV.
Okay, we'll enable the MTV. And we're going to get enough of API stuff to put down on the VTR up on the aft flight deck? Run.
Say again?
Still want us to pipe up API to the VTR on the aft flight deck.
Stand by.
Space Lab, for all of this is Marshal Ops on a correction of what you did with an item 7. Over. And Space Lab, this is Marshal Ops for Ulf.
Marshal Ops, go ahead.
Yes, Ulf, we want to check and run the O3 Alpha and check item 6. Over.
Okay, I'm going over.
And also a question for Ulf, whether you started 314 on time.
We hit the resume platform at mission day 2, 13 hours, 27 seconds. Correction. Mission day 2, 13 hours, 27 minutes.
Roger. And read back what the current value is after you gave an item 6.
Okay, happy item 6 and address is 004151. Is that the one?
Affirmative. That's affirmative.
Okay, current value is 000401.
Roger, thank you very much, Ulf, and please remove the 03 Alpha ECAS.
Okay, we have a problem with APIs. Before I remove it, I did the ephemeris update, but the OFD longitude and latitude is not the same as the longitude and latitude displayed on the VID.
Wolf, this is experiment 3. Did you perform in step 11 the 3 item entries that are listed on page CL3?
Stand by. You're talking about item 11 off the checklist, which is page Charlie Lima -3. Is that correct?
The 3 item entries that are listed on page CL3 should have also been performed, although the check current values that are currently in those locations are not as indicated. But they should, the item 7s and item 8 should be performed.
Yes, I performed item 6 and item 7 and item 8.
I copy. We would, we'll review the data after we get it down from the next run and follow up on the next update. We should proceed with the next run.
And this is data for martial ops. For the item 7, I used the value 000401.
That's correct. That's the correct entry for the step 11 as voice uplink. But the other steps in the original procedure on page CL3, the other 3 item entries should have also been performed.
Okay, then I have to go back and do that another time because that was not really clear to me that I am supposed to do that also.
Okay, well, we know what's, we can check it the next time then.
Okay, yes.
Say again?
Break off this martial ops. Can you make sure to remove the O3 Alpha and all the other things? Item 7s will be done later. Over.
Okay, roger that. Martial ops, the A03 Alpha is removed.
We copied.
TOCC Space Lab.
Go ahead.
Yeah, we apparently, although we had a dep ready up until that point, we apparently have a dep ready no currently. And when we came to T0, the recorders and everything started, but the thing did not fire. Even though, as far as I can tell, all the other conditions are met, for some reason, dep ready went to no, and it did not go.
We copy, Bob.
You guys see down there?
Bob, this is CPAC. Is DEP opt?
Affirmative. Stop.
Roger. CPAC for Bob. Let's go for the preparation for our model number 7.
LOS 20 seconds.
All right, so take out your last number.
Model number 7, just the same one in sequence.
Okay, but the thing is, it's not sequencing, I don't believe, or recognizing, since it never started. I'm not recognizing a shutdown or anything.
Okay, Bob, the CPAC's looking at that. CPAC for Bob.